We are just about to get started. We're at the top of the hour. We don't want to lose any time since we have 3 wonderful presentations today. So as people trickle in, I'll just orient you so that you know if you're in the right webinar or not. This is the National Harmful Algal Bloom Observing Network, webinar number 11 for our community of practice. Yes, we've had 11 of these. We'll be the 11th one. It's pretty amazing. We've had a couple years of really informative webinars, and I'm delighted to welcome you on behalf of a very nice large team of people who are advising on this. This includes my co-chair, Quay Dorch, and also a really vibrant community of harmful algal bloom experts and managers in the US who are helping us via the scientific, or the steering committee that is engaging in the community practice. I think I'm seeing slides flashing on and off, but we can move on here and just get going on what today has in store. So quickly, I'll remind you what NHABON or NHABON is all about, where we hope to be going with this experiment. And then we will launch into to some presentations, and these will be the 3 folks who are going to present on the UN decade. And this is a really interesting set of talks because we want to really synergize with what's happening globally right now. So not just the national setting on harmful algal blooms, but how is the world looking at oceanography, marine hazards, freshwater hazards through this lens of the UN decade of the ocean, and how we can contribute to sustainable development goals. So we brought some people in to inform us on some synergistic projects, and I will introduce them in just a bit, but we'll give you some background first on NHABON. So yeah, go ahead, Quay. I wasn't sure if I was transferring it to you on this one or not, but it looks like I am.
Yeah. I think we could both do it in our sleep. And probably many of the audience has seen these couple of slides before, but in case there's people that are new, NHABON is an idea at present. It's not something that actually exists, but we are working towards making it exist. So it would be a sustained national network for regional HAB observing. And as you know, we have all sorts of HAB observing going on around the country and globally. So the purpose of NHABON would be sustained observations for HAB detection, early warning, and forecasting, to better understand, predict, mitigate, and manage HABs, to reduce HAB impacts on society, economies, and the environment, and to better understand national HAB trends and impacts of climate change. That's a tall order, as I think you could all imagine. But once we have all this data, we need to do these things with it. Could we have the next slide? So NHABON, as we conceive it, and we started out being a small group, and we've slowly grown to this much larger group that is interested in this concept, started out in NOAA and envisions that there would be observing entities around the country. And the gray arrows are the flow of funds. The dotted lines are the flow of information. And each of these observing entities would have perhaps lots of partners or a few partners who would be contributing to have observations in that particular region. And so the purpose of this is a diffuse system, but to take advantage of the scale of it to come up with common solutions and to use the data, make the data available to everybody, and to be able to answer some of the larger questions. So back to you, Clarissa, sorry.
It's okay.
I've been cooking for 30 just now.
You get a pass. Yeah, so as I was saying, we have a few speakers here today. It's my pleasure to get to introduce them. I know all of them personally. So first up will be Dr. Meghan Cronin. She is co-leading the UN Decade program called OASIS. This is Observing Air-Sea Interaction Strategy. I've had the pleasure of working with her on this now for a few years. It was also a SCORE working group, and a lot is happening in this space. It's an incredibly vibrant global community. You will hear more from her on this as she speaks, but she's a physical oceanographer at NOAA's PMEL, that's Pacific Marine Environmental Laboratory in Seattle, where she leads the Ocean Climate Solutions Group, which maintains 2 long-term ocean sites series stations. And I'm sure many of you oceanographers know a lot about ocean sites, and is lead PI on a project to integrate uncrewed surface vessels in the tropical Pacific observing system. And she's a member of several international panels, so not just working on UN Decade, but other international groups. For instance, GOOSE, the Global Ocean Observing Systems, and she works on the OceanObs for Physics and Climate Group, which is OOPC. That's a panel. And also the Ocean Sites Executive Committee. So notably, she has over 100 peer-reviewed publications and is a fellow of the American Meteorological Society. So it's a real honor to have her here. Our next speaker will be Dr. Zachary Gold. He's the Ocean Molecular Ecology Program Lead at NOAA PMEL, also in Seattle, Washington. His research seeks to leverage the advances in molecular biology to scale biological analyses with physical and chemical processes and allow for characterization of marine ecosystem response to climate change and anthropogenic stressors. He's also a co-lead of the West Coast Ocean Bimolecular Observation Network. So he'll be talking about OBON today, which is a UN Decade program. It's global, but he's the co-lead on the West Coast component. We'll hear about that. This is a project under OBON. It was one of the earliest ones endorsed. Margaret Lynan here at Scripps, where I sit, is a lead on that. And so I'm really excited to hear about this because I've had a chance to work a lot with Zach on West Coast issues and think about eDNA and how to integrate that into a lot of things, including HAB monitoring. And then next up is Maggie Broadwater. She is someone many of us know here in the US due to her role in harmful algal bloom program management at NOAA. So she's a US government representative and vice chair of the IOC. So that's the International Oceanographic Committee, and FAO, so Fisheries, Intergovernmental Panel on Harmful Algal Blooms. Maybe many of you have probably heard of IPHAB or IPHAB. So that is a group that she is on representing the US. She's a physical scientist and program manager with NOAA's NCOS, that's the National Centers for Coastal Ocean Science. And she works across NOAA with other US agencies and global partners to advance understanding, detection, prediction, control, mitigation, and response to harmful algal blooms. Maggie lives in Charleston, South Carolina. All right, so don't want to hold up the show here at all. I want to switch things over and get our first speaker on board. So that will be Meghan. She will share her screen.
Unmute.
I know
Okay.
that go-to can be a challenge even when you've done it 4 times.
Yeah, so thanks a lot. And thanks for the introduction, Clarissa. This is really great to be able to speak to this group. So I'll be talking about the Observing Air-Sea Interaction Strategy UN Decade program, which is developing a practical integrated approach for observing air-sea exchanges associated with the energy cycle, water cycle, carbon cycle, and life cycle, all in a holistic way. I'm a co-chair. There's also co-chair Krista Marandino from Germany and Seb Swart from Sweden. So I want to start by just talking about myself and my pathway, and also kind of ways that me as a physical oceanographer might work with you know, in the HAB community. So I lead the Ocean Climate Stations group at NOAA PMEL, and we maintain 2 moorings, long-term moorings, the Keo mooring and Station Papa. And these are really community moorings. And so we have a sediment trap at Keo. Jamstack, our partners, have a sediment trap. We have partners in the carbon group that have a whole suite of ocean acidification measurements and air-sea CO2 fluxes. And we're really welcoming others, if you have some sensors or systems that you would like to put onto these sustained moorings, then talk to us. It has to be on a not to interfere basis with the other measurements, and also it has to be open data and shared with the community in the spirit that we're doing here. I also co-lead, I'm lead PI on these missions of uncrewed surface vehicles. They've been sail drones so far to the tropical Pacific. And in the last couple of missions, we've also have brought in fisheries partners from the Pacific Islands Science Center out of Hawaii, putting an EK-80 onto the sail drone. And so that is my entry point, and really the entry point into OASIS was through Ocean OBS 19, where we were, as a community, asked, what are the ocean observations needed to make transformative change over the next decade? And I wrote a community paper on air-sea fluxes with a focus on heat and momentum. The net surface heat flux has different components, radiative components, turbulent components, but really what's needed to measure them is like 7 to 8 parameters. And you have to measure them really well to get them accurate. But really, to get global, we need to have satellites to do this. And we kind of went through all of the different variables and how well they are, and what it would take to get these to be adequately measured from space, well enough to measure fluxes from space, and ultimately put into models and to get the proper kind of temporal and spatial resolution to resolve the ocean influence on weather and climate, to resolve the forcing on the ocean, and to be able to map out the effects of carbon dioxide globally. And so we came up with these measurements here, really, and or these recommendations, and we presented them at the Ocean OBS 19. And my paper here was just one of many community papers, even though I had 30 co-authors from around the world. And we realized that if we were going to get any of our recommendations done, we had to work together. We had to work with the carbon community, with the HAB community, with us, and we had to think beyond, our siloed visions of, just in situ or just satellites or just models, but really see how these are all linked and work together. And so we came up with this OASIS came up with this 3 grand ideas that were kind of would harmonize all of these different recommendations from all of these papers related to air-sea interaction. The first is that we wanted to have we need to have a globally distributed in situ air-sea observing network built around an expanded array of time series stations. And it's going to be a diverse network. Some of these are kind of dreams, and some of them are new technologies that with our efforts we can make into global sustained networks, like the uncrewed surface vehicles. These will then feed into tying down and tuning and validating and learning how to optimize the satellite network. And then these would then feed into the improved models. Our grand idea 3 is that we need to have improved understanding of these air-sea interaction processes and improved models. And then together these would lead to improved information that would serve to create a more predicted ocean, clean ocean, accessible ocean, healthy, safe, and productive ocean. But, you know, being a UN Decade program, we have a theory of change. And this has turned out to be very, very important and impactful. So we took our biggest challenge, which is that we have to measure all of these variables, 7, 8 for net surface heat flux, you know, another 6, 7 for carbon fluxes, and we have to measure them all together, co-located, preferably on the same platform. And it's really too much for one person. We have to work together and bring in experts, you know, as partners, and really develop a culture of mentorship and partnership to work together and to make these platforms multidisciplinary, multifunctional, to be able to do this. And it has really gained traction. It's been a lot of fun. We had an in-person meeting right before Ocean Science meeting. We had more than 54 people. There was 54 people in this picture with early career ocean professionals from Africa, South America, Asia, Australia, Europe, and North America. And really, we envision, well, the mission is to develop this practical integrated approach for observing air-sea exchanges, associated energy, water, carbon, and the life cycles, and to create a pathway to get involved in this science for sustainable development. And so we have a whole bunch of activities. We have associated with these grand ideas. We have, you know, we're trying to develop a dream team for technology development. We have a very active group that is working to create a community of practice for uncrewed surface vehicle networks and actually make this into a network, an emerging network of the Global Ocean Observing System. That group has a webinar series that kind of is building up this community of practice. The satellite group is also a very, very active group, and they have a weekly webinar series that is just phenomenal, and it's on YouTube, and I really encourage especially students to take a look at these talks. They are just great. The Grand Idea 3, improving the hierarchy of Earth system models and air-sea interaction. We are trying to build international partnerships to expand process study field campaigns, and there's a lot of other activities that are kind of being talked about that can, you know, with more work and bringing in people, we could really make happen. Our theory of change is probably where a lot of our activity is into doing these best practices, developing partnerships and capacity strengthening, and then the FAIR data has had a lot of work with teams kind of developing vocabulary and toolboxes and other things. All of these activities can use biological and the HAB perspective. So please look at our website and then go to our Get Involved links, and I really hope that you can join us and that we can do work that can bring in this life cycle part to all of these air-sea interactions. Okay, thank you.
That was excellent, Megan. Thank you, and
Yeah.
thanks for keeping it on time. That was fantastic. It's great to hear about this program and how we can plug in globally and think about models, satellites, global OBS, and our role in that. So next we will move over to Zach Gold, and he is going to give us a molecular perspective. Take it away. I can't hear you, Zach. Is it just me?
Need to unmute. Apologies. Thanks, everyone. Hi, everyone. I'm going to be talking today about OBON, the Ocean Bimolecular Observation Network. And I want to acknowledge that I'm one of the co-leads with Susie Thoreau and Nastasia Patton at SCORP, and Nastasia and Aaron Satterthwaite at Cal Coffee. And I had help from this, putting together this presentation from our wonderful postdoc, Samantha Seta, here at PMEL, who is a real HABs expert. And I'm running our molecular group and have much more than molecular background there. So great. So I just wanted to, acknowledge from a social standpoint, HABs are really important, right? They impact our lives. And here recently in the Pacific Northwest, we've been having a pretty severe harmful algal bloom, sent people to the hospital, and it is impacting our aquaculture fisheries as we speak, right? And so this is why having a national harmful algal bloom network is so critical, because we don't have these observations. This impacts both our economy and it impacts public health, right? And so that's why we need this information. And one of the things that is critical for our ability to be able to predict and understand and forecast harmful algal blooms is really linking all of this data at once, right? And so one of the hallmarks that I think our program was stood up at Pacific Marine Environmental Lab and PMEL has been involved in for a long time is really this idea of closing the loop and having these co-located essential ocean variables where we have our information on everything from trace metals and micronutrients to the carbonate chemistry to the oxygen temperature alongside our biodiversity and our ecosystem data, so we can actually understand how, when, and why our ecosystems are responding to the environment and how those ecosystems are impacting the physics and chemistry that we're observing. And so this same spirit is really what launched the Ocean Bimolecular Observing Network as one of the early UN Decade of the Ocean Science Sustainable Development endorsed projects. And so just to orient folks to OBON, this is being led by Margaret Leinen as the chair at SIO, but with many partners globally and with over 100 endorsed projects around the world. And the idea with these really is to develop and advance our biomolecular observations and to support projects that are addressing a whole suite of key science objectives, including HABs. Is building off of what OASIS is doing as well, developing a lot of these best practices. Environmental DNA, yes, technically has been around for the last 20 years, but I would say in terms of operationalized biodiversity monitoring has really been in the last 5 or so, and it's rapidly evolving as we get much better at being able to do these methods. And then as well as to support training technology transfer, particularly thinking about underserved and developing nations that don't have necessarily the same high-end sequencing technology that we have. Also wanted to shout out that this aligns really well with recent advancements in the from the White House and the National Aquatic Environmental DNA Strategy, and just a specific call out here, here using autonomous eDNA sampling meant to coordinate across all the federal agencies for both marine and aquatic areas using biomolecular methods for observations, including for harmful algal blooms. And so who are we in West Coast OBON? So we're a group of 15 institutions across the West Coast, all the way from British Columbia down to Southern California. This includes an incredible group of world leaders in marine omics, with hundreds or probably closer to thousands of publications that have come out on eDNA and eDNA related work across all the different partners. And so really the goal is to leverage this incredible regional expertise to advance our biomolecular observations and really start building this community of practice, instead of all of us doing things in our our little backyard. If we start integrating these across scale, we can start answering these really big questions that we've all been interested in. So we have a handful of objectives here. Importantly, really identifying the gaps to interoperability. One of our main goals is to be able to take the ballpark 25,000 eDNA samples that have been taken over the last decade from different programs across the West Coast and integrate them into a single data set, so we could answer questions about how phytoplankton or communities are responding to different ocean conditions. And to do that, we're doing a handful of intercalibration efforts and developing best practices, sharing our resources, as well as addressing these scientific management and policy questions. And one of those in particular is the identification and forecasting of HABs here, and understanding the relationship to changes with climate change and changes with water quality and ocean acidification hypoxia impacts. So we have a handful of efforts, but the ones that are most related to what we're talking about today are, the harmonization and standardization of eDNA methods and developing, what are those best practices, particularly for using eDNA for phytoplankton communities, and as well as pushing the eDNA field into this fair data management, this findable, accessible, interoperable, and reproducible data management, and to build towards integrating of our data streams. So won't dive into the weeds here, but a lot of that is like developing these reporting standards and templates that everyone can start using. What are the best practices, and a series of papers that we're working on right now, identifying those, and then coordinating these data mobilization workflows. And in particular, we at OMICs have developed this data lifecycle for eDNA that didn't exist until this February. And so really, how do we mobilize all of this data into public repositories, this genetic sequence data, these biodiversity observations into the Global Biodiversity Information Facility, GBIF, as well as OBIS, which OBIS, right, is a node that connects to the harmful algal bloom information system. And so by getting all this data in there, we can then support the downstream harmful algal bloom observations. And so really building this system from scratch, all of the things listed in gray here are pieces that they exist, but are not formalized. And so we need to build this whole data management stream. So it's a little bit of building the bike while we're riding it, but we understand how important this is. And I'll just highlight that there is this really big need collectively within the community. It's amazing seeing how far the climate community and where OASIS is, being able to push and similar, global observation for climate-related data, but biodiversity data has not been mobilized in the same way. And so we need to really push for this. And so we're, that's a lot of what we're working on in building these tools, having this dedicated data management infrastructure, these, standardized formats and specified workflows. And really we can, establish these extensive calibration integration efforts so we can be able to produce these large scale biodiversity products, including, harmful algal bloom products. And so, we understand that eDNA is one tool in the toolkit, right? And so I just highlight a suite of tools that people have been using and are using for harmful algal blooms, whether that's imaging flow cytobots or other kinds of imaging systems and artificial intelligence, remote sensing, visual identification, and toxin analysis. And really, we need every single tool in the toolkit to be able to do this, best. So one of the advantages of eDNA is it's relatively cost effective, and more we're being able to automate this, and it is able to get down to really fine taxonomic resolution. And there's more and more work being done where we can use eDNA or similar omics tools, eRNA approaches, to be able to do toxin analysis. And so it might alleviate some of the budgetary constraints or ability to sample spatial and temporal scale that we really just can't scale our visual identification. There's just not enough taxonomic experts or enough toxin analyses that we can necessarily do at a national scale without dramatically changing our funding sources for these, right? And so I think it's really bringing together these different efforts so that we can better understand how harmful algal blooms form, when an algal bloom turns into a harmful algal bloom, and then being able to forecast and predict that. And so I just wanted to highlight, the West Coast is really a snapshot. I think we have an incredible ability because we have such incredible observations. So we have imaging flow cytobot stations, both being deployed at sea, as well as, on piers. We have, this incredible list. Those little boxes are where our different West Coast OBON eDNA monitoring programs are taking sampling. This is where those 25,000, eDNA samples we've estimated exist in this region. And then, of course, one of the test beds of hyperspectral resolution, both from aerial surveys as well as now, of course, the PACE satellite, right? And so we have the ability to start integrating these across, these different scales, different observation techniques, so that we can do a better job of understanding when and where harmful algal blooms, occur, and how can we better predict and forecast this in the future, right? And so, just a shout out and the call to need to start measuring all of these information simultaneously. We can't just be looking at just the algae without looking at the environmental data and vice versa. And it's all of this is really important for improving our ability to fundamentally understand what takes an algal bloom and makes it a harmful algal bloom, and really improve our forecasting ability to provide the people that need the data that closer to real-time information. And so there's a lot of collaboration and coordination that I can see here, right? Ensuring that in the future, all ocean stations are integrating different observations and have the ability to get HAB kind of monitoring data. Obviously, the next talk we're going to hear from Harmful Algal Bloom Solutions, there's a ton of work there on synergized dating resources and innovative observing instrumentation, and obviously omics plays a really important key element to that. And of course, this aligns really well with dozens of other UN decade programs. There's at least 30 that are eDNA focused, which is really incredible, as well as obviously the World Ocean Data Management efforts. And so with that, just want to end on this really important need to have co-located measurements so we can start being able to better predict and forecast harmful algal blooms. Thanks.
Wonderful. Yeah, that last plot really illustrates why we brought you and Megan and others here today, is to think about that integrated perspective, that we can't do ecological forecasting the way we want to do it without all this co-location and thinking broadly about biodiversity. HABs are one aspect of biodiversity, as you eloquently noted. It's not some special use case, it's everything we're doing. So thank you so much. And I want to introduce again Maggie Broadwater, and apologize that I did not say you would be presenting on harmful algal bloom solutions. I missed that earlier, but here we are. HAB-S, take it away, Maggie.
Thanks, Clarissa. Is everyone seeing the right screen? Just the slide screen.
I mean, we're seeing the notes with your PowerPoint. It's not in.
Oh shoot. Okay, how do I unshare?
There we go. There it is. Perfect.
You're good.
That one looks good.
Wait, now it is the right screen?
Yeah, now it's good.
Okay, I didn't change anything.
That's okay.
All right. Well, whoops, let me go back one. So first, I want to thank the National HAB Observing Network Steering Committee for inviting me to share the HAB Solutions program in this forum, and also thanks to Megan and Zach for highlighting the other UN Ocean Decade programs. I'm still learning about the programs and different synergies, as the HAB Solutions program is a newer program that was just recently endorsed. So I'm looking forward to learning more about these and others as well. First, some background. The international HAB community interacts and works collaboratively through an intergovernmental panel for harmful algal blooms that Clarissa mentioned in the introduction. So the panel works through the members of the panel and also all of the related entities that are shown here on this slide. The panel is co-sponsored by the Intergovernmental Oceanographic Commission of UNESCO and the Food and Agriculture Organization of the United Nations. So the members of the panel are composed of government-appointed representatives from the different IOC member states and also select advisory members. So currently we have 55 countries represented across 6 continents, and this includes 2 small island developing states and 2 least developed countries, which are specific focus areas under the UN Decade for expanding science in these regions. Philip Hess from IFREMER chairs the panel as the representative from France, and I serve as both the U.S. government representative and the panel vice chair. And Don Anderson from the U.S. National Office for HABs at Woods Hole is the U.S. advisor. The Global HAB Research Program, different working groups and regional networks that are shown here are also represented on this panel, along with IOC and FAO. And the panel meets every 2 years to set a work agenda for the intersessional period, with activities conducted by the Global HAB Research Program, task teams, working groups, and regional networks during the intersessional period. An additional task team was added at the 2023 meeting to propose a new HAB Solutions program under the UN Decade of Ocean Science for Sustainable Development. So this program, the HAB Solutions program, was formulated by the task team leads from the Intergovernmental Panel, and that was at a meeting in April of 2022. And it took a little while after that to fully develop the proposal. It was submitted by the IPHAB to the UN Decade of Ocean Science for Sustainable Development for endorsement in November 2023. And it was endorsed as a UN Decade program in January of 2024. So what is HAB Solutions and how will this be different from the programs that already exist? What is this program aimed to do that is not already happening under the Intergovernmental Panel, the Global HAB Research Program, or the International Society for the Study of Harmful Algae efforts? What we're aiming to do is create a comprehensive global HAB science and management program that aims to link the scientists studying harmful algal blooms and their impacts with local and regional stakeholders directly impacted by HABs with the purpose of advancing solutions. So we need your help as the HAB science and management community to do this. The overarching goal of the program is to provide novel and transformational science-based solutions for sustainable management and use of marine resources and ecosystem services affected by harmful algae in a changing world. These solutions are going to look different in different parts of the world. There are 4 different initiatives under the program. The first is prevention, really aiming to prevent, control, and mitigate harmful algal bloom events. The second is advancing harmful algal bloom observing tools and technologies. So really expanding the tools in the toolkit that Zach showed on his table slide a few minutes ago. Also advancing equitable and accessible harmful algal bloom data and improving HAB literacy. We know that HABs are very difficult to understand and to communicate. They can be very difficult to study, and we're aiming to inform different communities about what their risks are in a way that they can better understand. So what differs about this from existing initiatives is that we're really trying to incorporate the mantra of nothing about us without us to involve affected communities and stakeholders in co-created science initiatives. I'll go through each of the initiatives and provide an example. And while the focus of this webinar series is on observing, you'll see as I go through that all 4 initiatives are really linking to observing in some way and are kind of interacting with each other. So starting with the PCM initiative, the overall goal is to reduce the frequency and severity of harmful algal bloom events. So when we say events, we're including the impacts. So while reducing harmful algal blooms would be ideal, it's more practical and achievable to focus on reducing harmful algal bloom event impacts, both by preventing and controlling HABs and by reducing impacts on industry, food and water quality, human health, society, and the environment in the ways shown here. So the desired outcome is to mitigate harmful algal bloom impacts on coastal and marine ecosystems. And this can be through early warning systems, safeguarding aquaculture, harmful algal bloom control technologies. Traditionally, most of us know that useful technologies have involved both phytoplankton monitoring of water bodies and toxin detection in seafoods or for the purpose of evaluating effects on humans and wildlife. Early warning is essential for managers, industry, and communities to mitigate the impacts associated with harmful algal blooms. In 2022, technical guidance for the implementation of early warning systems for harmful algal blooms was released jointly by the FAO, IOC, and IAEA. The goal of the guidance is to provide nations and communities with the ability to develop region and HAB-specific warning systems. So basically, so communities can answer questions like, if I fish or harvest seafood, is it safe to eat? Will my business or livelihood be compromised due to a harmful algal bloom? Is it safe to swim in a certain body of water where a HAB is occurring or has occurred? Does the government need to issue warnings due to the presence of toxins in water or food sources? Will a HAB event have detrimental effects to an ecosystem or marine life? You can see here that we've made some advances in the global availability of harmful algal bloom surveillance, and the number of countries has increased in time since the bottom picture was published and this was about 20 years ago. So there was a pretty a good advance in from 1996 to 2001. We've had some advances since then, but there are still large gaps in regions of Africa, the Middle East, the Far East, India, Central America, South America, and the Pacific Island states. The Harmful Algal Bloom Solutions Observing Initiative aims to co-develop and implement novel transformational technologies for enhanced detection, monitoring, and mitigation of harmful algal blooms and their impacts on coastal marine resources. So this observing, of course, is going to be region specific to address differences in infrastructure and capacity. In many areas of the developed world, there is already a fair amount of observing infrastructure in place. And then in other areas, as I just showed on the previous slide, there's really nothing there that currently exists. And those areas are at risk as well. So the desired outcome is to improve ecosystem observation through the development of transformational instrumentation and approaches. And again, these can be as basic as phytoplankton monitoring in areas that currently have nothing, and as advanced as the imaging flow cytobot or environmental sample processor that can simultaneously detect the presence of harmful algae and toxins in different areas of the world. Alaska serves as an example in the United States where communities are directly engaged in driving observing efforts to directly serve their specific needs. Alaska Native tribes and tribal organizations are currently using toxin detection technologies that are suitable for remotely situated laboratories to support tribal aquaculture and subsistence use within their communities. In many regions of the world, like Alaska, communities and families depend on the ocean for food, as they have for generations. These subsistence communities often have to make choices between healthy traditional foods from the ocean that may be contaminated with harmful algal bloom toxins and less healthy and extremely limited choices from other sources. The subsistence lifestyle has components related to nutrition, culture, and economy, and harmful algal blooms can compromise all of these in regions that already face many other challenges. The tribal and community toxin testing efforts that are shown here began when the Sitka tribe of Alaska established their own research laboratory in 2016, and it's continued and expanded with increased communications among Alaska communities, facilitated both by the Alaska Ocean Observing System and the Alaska Harmful Algal Bloom Network. The labs shown here are at various stages of operation, but they're moving toward establishing a network of laboratories with toxin testing capacity to support the nutritional, cultural, and economic components of continued subsistence use in Alaska. The Harmful Algal Bloom Solutions Data Initiative aims to co-create and maintain equitable and accessible harmful algal bloom information products in partnership with users and stakeholders in all regions of the world. So one thing that's come up across these discussions is interoperability and having data products that seamlessly feed into each other. Zach mentioned that as an example of OBOSS and the harmful algae information system that's shown here in the previous presentation. The Harmful Algal Bloom Literacy Initiative aims to develop a suite of literacy and outreach outputs to meet HAB-related human health, ecosystem, seafood security, and global change issues. Harmful algal blooms and their related risks are complicated and difficult to explain and understand. Whoops. So Harmful Algal Bloom Solutions addresses the three, you can see we check a lot of the boxes here when it comes to the ocean decade. We're addressing the 3 ocean decade objectives, contributing to 9 of the 10 ocean decade challenges and 4 of the 7 ocean decade outcomes. And here on the timeline, you can see that we're coming in late. We were just endorsed in 2024, so all of these other programs that are shown on this slide are ocean decade programs that we likely will have different synergies with. And I'm hoping that we're learning from the other programs and also working with the networks that have already been established under those. We have OBON and OASIS both listed on here. And then a lot of the other, the programs that are listed are also potentially have synergies with harmful algal bloom solutions. And then there are co-stressor programs on here as well, addressing hypoxia, ocean acidification, and nutrient pollution. And then lastly, I wanted to mention that last week, for the first time, harmful algal blooms were included as part of the UN informal consultative process for the oceans and the law of the sea as part of an overarching focus on the ocean as a source of sustainable foods. And the presentations here addressed harmful algal bloom impacts to the safety and security of sustainable ocean food and the impacts to the 3 pillars of sustainable development. So HABs can impact the environment, society, and the economy, as was mentioned in the introduction. And this is a focus that is really becoming, it's getting a lot more attention than it's gotten in recent years. Another example of that is a section in the recently released State of the Ocean report under the progress toward achieving a safe ocean during the UN Ocean Decade. The section highlights the information compiled in the 2021 Global HAB Status Report. And the world map shown here shows the distribution of events associated with paralytic shellfish toxins in red, combined with that of the occurrence of Alexandrium causative organisms in blue. The larger the bubbles, the more events were observed in a locality. This is one example of the information that can be gained from the harmful algae information system that currently exists. So this is not comprehensive, but it's a list of people who are already working in the spirit of the HAB Solutions program. I'm sure that people representing some of these programs are on here. I know that some are on the introductory panel. So we're at the beginning of an effort that will take us through 2030 and beyond, and we need your help for the success of HAB Solutions. The inclusion of HABs in the UN Ocean Decade at the ICP 24 meeting, and also as a special section in the report I just mentioned, demonstrates that global attention is shifting to address the significant risks related to harmful algal bloom impacts on the environment, society, and economies. We're looking to all of you as members of the global HAB science and management community to participate in the effort as regional and community partners to ensure we're effectively serving harmful algal bloom impacted communities everywhere through solutions that meet their specific needs. Thank you for your attention.
Thank you, Maggie. Nice overview. I'd like to turn it to questions since we only have about 10-ish minutes left. We have gotten a few in the chat. I'll try to field the first one from Ajit Subramaniam. This is for you, Zach. Your sound did go out briefly, so I think some of the things you were saying about autonomous platforms got missed. So regarding eDNA collection on autonomous platforms, can you speak a little bit more to how much of that's happening now? What does that technique and methodology look like?
Yeah, absolutely. Sorry for cutting out. You know, I think the tech is developing really rapidly. And so there are, you know, a handful of fully autonomous systems that exist. In particular, I'd point out the environmental sample processor that was developed by Mbari, and the version 2 is now commercially available through McLean. As an example, that can do like end-to-end, collect a water sample, filter it, and actually do toxin analysis in some cases in real time, close to real time, you know, within a couple hours of sample collection. But those are, you know, quite expensive instrumentation, and they have not been deployed, you know, at scale. There's a lot of innovation in this space. Just at the 3rd National Marine eDNA Workshop, there was a whole, you know, Confluence subsection that was just about developing, you know, better autonomous infrastructure. And I think there's a lot more work that needs to be done in both just the sample collection phase, but also doing the kind of sequencing at sea and getting to the point where you might be able to get, you know, real-time updates. I don't think we're quite there yet, but there's definitely a lot of innovation in that space.
Yeah, a lot happening. Hopefully that helped, Ajit. And Kelly Broom has a couple of questions. I think this also was really more directed at you, Zach, but probably anyone can really address this. Will there be a push to have open source studies available so the public can reference them? And I'll let all of you address that, starting with Zach. Yeah,
I think the big push right now is to make all of our data, not just open source, but actually like that's the fair, and it's like actually usable so that somebody can download it and run the analyses themselves, and import that data. And so right now, a lot of the eDNA data, like our papers are open access, like you can find them online, but then you have a metadata file that, I as a PhD student maybe did, and then even as a postdoc might be in a different format, and then a different lab does it in a completely different way. So it isn't standardized and harmonized, so that way, another research scientist can come in, or a program manager or whoever, and like have all the data in like one nice data table that's formatted, and you could like plug and play analyses. And so I think there's a really big push within, certainly within West Coast OBON, within OBON as a whole, to build that infrastructure for data management and data serving out so we can provision the data. So it is like truly, open access, and anyone can get a hold of it and use it.
Yeah, and I know, Megan, I'll turn it to you, since I know you're thinking quite a lot about this with the theme teams and the themes.
Yeah, Zach said it really well. It's the same with OASIS. We have part of our theory of change is having fair data, which is findable, accessible, interoperable, and reusable. And there's a lot that goes into that. Being able to have the metadata and have it all be machine readable, so that there's a standardization of vocabulary, of standard names, and so that's a lot of work. There's hard work that goes into that, and we need your help to do that. And we have all of our groups, our task teams, theme teams at OASIS are co-led by early career. We try to pair early career with leads, with senior leads, so that people get a lot of networking and get to know things in new ways, and but really give leadership opportunities to the early career. Yeah.
Clarissa, I would agree with that as well under HAB Solutions, and specifically with the work that the IP Hab has already done to make sure that new products are interoperable with the harmful algae information system, and putting that information out where it is accessible to all. There was a presentation at the US HAB meeting in Albany a year and a half ago that Nick Record actually gave the presentation, and some of those concepts that he presented went into consideration when we were developing the summary for the data initiative. And it's really getting at representation and fair data principles combined to produce equitable data that is accessible to everyone.
Yeah, and a lot of this sometimes comes down to the publications, and I suspect some of this question is really oriented at that. Kelly had a follow-up, which is that she said, I'm also now noticing that Google is reducing access to research queries in their search engine, and sometimes that does hinge on some of the copyright stuff with pubs and other things, but as a community, we have our eye on this, and we need to keep pushing forward. And I don't see any more questions coming in. If anyone else sees something, oh wait, Becky has one. Sorry, Becky, I just saw it. So Becky Stanton wants to point out that she really appreciates Maggie's presentation and involvement in this effort. Can you expand on how the global scale resources will be applied at a regional scale where HAB modeling may be more practical and feasible?
So I would say what's happening in the US is a good example of that already. Certainly there are regional models that are serving different areas where HABs are occurring, and there's a specific need to understand kind of what the impacts are and how to get ahead of those. Clarissa could probably speak to this better than I could with regard to activities in Southern California, for example. There are others who may be on related to the other regions. But yes, so that it's definitely going to be a regionally driven effort that is compiled together. And we want the one idea is we want HAB Solutions to be more than a compilation of all of the things that already exist. which we could pull in under the umbrella because so many good things are happening in the regions where there have been more advancements. But taking that and really putting it out and showing the rest of the world what can be done to drive information and change and seafood safety and considerations related to all impacts of harmful algal blooms and communities where that doesn't exist is the area where we really want to push and grow. So I'm not sure if that answers your question specifically, but it is definitely going to be a regionally need-driven effort, specifically with respect to the modeling.
Yeah, and I think this question applies to all of the UN Decade programs. I mean, Becky is landing on something that is critical. There's no easy answer. The UN Decade does not come with just sort of endless resources to go out to all the work that's happening at these regional scales. So what it really is about these communities of practice, local communities coming together and having a top-down influence on how things are done and how things do move from more resourced to less resourced regions. And I think that's what we're all kind of trying to get at. But it's tricky because if, you know, we understand that this stuff is place-based and we want to increase effort in the places where we are. But the UN Decade is going to be a little bit more of a slower operation in that regard in terms of mobilizing those resources, but it's happening and we're getting into what year 4, year 5 of this 10 years and hopefully things are starting to change. And I realize we're almost at the end, so let's move on to talk about the next webinar, unless there are any other questions that I missed. Oh, wait, a whole bunch have come in. Oops. I'm having a hard time talking and following them at the same time. And Ajit wanted to follow up on Becky's question. I'm curious to get Maggie's thoughts on international cooperation on learning from each other about OBS techniques, impacts, and solutions. And I think you've kind of said a little bit of that already. Let me just read Astrid's question. This is Astrid Schnetzer. Is there a process in place to collect eDNA with other, sometimes more targeted DNA data sets within your framework? HAB-specific DNA sampling has happened for a long time, but does not easily translate into eDNA approaches sometimes. But maybe I'm overthinking it, thanks. So I'll take that to Zach and then I'll loop back to you, Maggie, if there's a minute or two.
Yeah, I think, you know, this is why we're trying to align really well with existing biodiversity frameworks. And so GBIF has spent a lot, and OBIS have spent a lot of time through this group called TADWIG that are, you know, sort of the gurus on the taxonomy side of how to store biodiversity data to build those frameworks. And so, you know, by putting all of our data into these very large repositories that have already existed for taxonomically, you know, like you catch a fish, like the traditional methods, as well as like DNA sequences from, you know, doing sort of more old school barcoding or whole genome sequencing, as well as eDNA, all of those exist under that same framework. And so that it enables you to integrate any kind of observation, whether that comes from, you know, acoustics is the one that they're working on now, or from visual surveys or from eDNA, you name it, they can all fit in that same framework so you can integrate the data simultaneously. So that's a great question.
Thanks. Yeah, Maggie, do you want to loop back to Ajit's question? And Masha, can we throw up the slide on the next webinar just so people can see it while we're chatting? Thanks. So Maggie, I can't hear you.
Whoops, sorry, I was muted. So to what Ajit is getting at is really how to share the information that you're producing in one area of the world where there are other examples where either the models or the information could be useful in similar systems. It's what I think I'm understanding. And there currently we have not advanced beyond where we've already been for that, which is interacting at scientific meetings, traveling to different areas of the world, and sharing that information. We do anticipate creating better opportunities to do that, but it may be, it's likely going to be scenario by scenario as far as kind of a matchmaking process in doing that. But I welcome input on how to improve the process.
Yeah. Nice. This has really been helpful. I thank all three of you truly from the bottom of my heart. And I'm sad we have to wrap up, but here is the next webinar advertisement. So we're going to go from talking about these global programs to specifically observations, global observations down to regional observations from satellites. What are the advances in that space, the space-based part, a little bit less on the airborne. We've done some of that already. We'll probably focus this a little bit more on remote sensing from satellites, but not 100% that way, because there's a lot of HAB detection happening in the drone and airborne space as well. So please tune in for that. I think this is a really timely and important conversation. And thank you so much for attending.